Hello, Edward. How are you doing?
Hello, how are you?
Good, good. In the AWS Startup Loft and also with our current clientele, we get a lot of questions about LLMs, RAGs, and so on. So, that's something I want to tackle today and discuss a little bit what we see in the market. Maybe also do some short architecture diagram of a solution that we implemented for a client of ours. See how whatever we can discuss and see along the way. In short, for the people who are not familiar with a RAG, it's basically the retrieval of augmented generation. Like that's a complete name for RAG, and it's basically an AI framework for retrieving facts from like an existing knowledge base. In most cases, that's like a vector database, and it helps the LLM to be grounded to the latest information, but also that it's has like verifiable facts. So probably a lot of people have seen LLMs like start to hallucinate and stuff like that. Whenever they don't know the answer, they sometimes start making stuff up, which can be funny, but in like a professional context where there's decisions involved and stuff like that, or a customer success chatbot or whatever, it can lead to some consequences. Where, for example, there was a recent case that somebody bought a car super cheap because it was like proven to be valid information that the company provided and stuff like that. So that's something to be careful with. But the other great, and that's the greatest benefit I think for a RAG is basically um, it's a good analogy between a closed book exam and like an open book exam. So a RAG is basically like an open book exam. So whenever he doesn't know what to do, or doesn't have the information when it was trained, it can basically look it up and know where to look it up. So that's a very important fact about RAGs, but also whatever is most important, training LLMs is super expensive. Basically, it's that's where you see a lot of the pre-trained models in AWS or in other cloud providers being used. But it doesn't necessarily is trained on your information, so it sometimes can be like even not necessarily dangerous, but if you have sensitive internal information within your organization, it can be daunting to train the LLM model to know all this information. And whenever there's big updates to that information, you have to retrain the model over and over and over again, and that costs a lot of money. So basically, you can create an LLM, and then also, like if you see in AWS BedRock, for example, use predefined use cases, and you don't have to carry the cost of running the LLM yourself and training it and so on. So that's, in my opinion, the biggest benefit of the like of Rex, in short. So maybe what do you think? It was a long intro, but nevertheless.
Yeah, there's a lot of things to unpack here, I think, right? So there are a lot of people coming to us. I want to run a generative AI model. How do I start doing that, right? Um, do I create my own model? Are there models? Do I run a model on a server? So there are already different possibilities. And on AWS, the easiest way to get started is with AWS Bedrock. So Amazon has models. They expose an API. It actually works just like ChatGPT. If you use a
Yep.
ChatGPT API, then you send your question, you get an answer, right? So the Bedrock API, you send a question, you get an answer. You pick your model, right? You can choose whether you use Amazon's model, which is most likely the cheapest, but you can also use other models like Llama or something else. Um, and then you get an answer. But it's trained indeed on public data or proprietary data that's they put in there, but that's still kind of general knowledge, right? So it doesn't know anything about your internal documents. And the when you want to try to build a business, a new use case, well, the public models already exist, so there's nothing new. What can be new is that you have some documents, some information that you want to get into your generative AI model, ask questions about it, and get answers. And there are indeed multiple ways of doing that. So some companies, they will indeed create their own model. They will take some proprietary information that they have, put it in their model, retrain the model to contain that information. Then you give it a weight, like you can say, this new information is a very high weight, so it will a lot use that information to answer your question, right? But that's quite complex because you're changing the model, right? You are saying, you might do one training and then see that after you indeed spent all that money on hardware, renting the hardware, that you need another training using different ways of training, or different documents, or reformatting the documents or something like that. So it's already quite complex. But there are definitely companies doing this. And it's also the most expensive way because you need to buy or rent the GPU instances, right? The GPU instances are super expensive on Amazon if you have credits. So most of the people doing this, I've seen that they're trying to do something new, something novel. They have AWS credits, right? But if you don't have credits, it's quite expensive to retrain those models. So if it's just retraining with not a lot of data, or you don't need to have a lot of hours of GPUs, I guess it's okay. But if you need a lot of training hours, it can be quite expensive. And even there are new ways of training. There are companies specializing in cheaper hardware, or not training on GPUs, but on these LPUs, like specific hardware. So there's definitely a lot of innovation happening there as well, that you might not always need GPUs. But then there's this kind of, like you explained, this RAG is kind of a hack, right? So you say, let's not retrain our model. Let's use the model. But in our question that we are going to ask, we are going to provide the context. So we are going to say, okay, I have this document here of 100 pages. I'm first going to feed the document to my model. And I'm going to say, using this context, or whatever, you're just going to feed it, this is my question.
Yeah.
So this doesn't work with every model, because every model has a limit on the input tokens, right? So a token is a couple of words, or like there's definitely a mapping between them, but there's a certain amount of tokens that you can use. So just think about it as like a couple of words that you can use. If you reach at maximum, if your document is too long, it will not work because you reach the maximum.
Yeah.
But then there are other models like Claude, for example, that say we are specializing in big contexts, right? So that you can just send a lot of documents, that no retraining needed. That's their benefit. So if RAG is really your thing and you want to just inject a lot of information in your model, then Claude is, for example, a good model to follow, right? So you would then feed those documents and ask a question. So then the language model will go over your document and try to find the answer to your question. But not all models are like that. So not all models can provide such high input. And then even, okay, 100 documents, that will work. But what if you have terabytes of information, right? So then there's another approach. And this is the approach that we also see our customers using. The other approach is, let's use a vector database. We have our database. Let's copy all the data from our current database or databases, feed it to the vector database. Then when you have a question, let's first ask it the vector database, which will then give you an answer, just like kind of doing a Google search, right? That's how I see it, right? So you do a Google search, you have like, let's say you have 10 results that match. And then that result that you feed back to the language model, or the document that is number one, or the first 3 documents, giving this information that I found here in my vector database, and I'm supplying this information, give me the answer. Right? And then it can still give a good answer, but you didn't have to supply all these terabytes of information, because terabytes, gigabytes, those are in your vector database. And then another interesting something that happens, Amazon also saw that this is an approach that a lot of companies are taking. So they built a service for that knowledge base. So within BedRock, you have BedRock knowledge base, and they can help you not to have to do this manually. You can just say, I have my S3 bucket, I have all these documents in there, and these documents I want to have in my vector database. You say, here's my vector database, OpenSearch, Elasticsearch. Actually, just OpenSearch is supported, or Pinecone, but this will definitely change in the future. And then it will, for you, populate the vector database, and then it will do all like the connections in between, and you just have your endpoints that you can ask the questions. But then we also saw that not a lot of our customers are using this product because it has shortcomings. And what I just said, it has OpenSearch. OpenSearch means it's OpenSearch serverless, OpenSearch serverless only. But then often companies already have maybe the non-serverless version running as a vector database, or just want to use Elasticsearch, which are currently not supported. Maybe in the future, yes, but not right now, no. So you already have to pay quite a lot of money every month to get on this serverless version. You would think serverless is cheaper, but actually the baseline is actually much more expensive. So running knowledge base, running this on AWS is already quite expensive.
Yep.
So it might be worth more. It might be worthwhile to do this manually and just I have here my S3 buckets. I'm going to use something like Textract or some other OCR software to extract the text out of it. Then I have my text. This is text I'm going to feed to my vector database. Can be Pinecone, can be something, whatever, vector database. And then I'm going to make this link, maybe with BedRock, maybe with ChatGPT, maybe something else, to then get to the actual answer. So that's also something that works.
Yeah, absolutely.
And then when I then start discussing this, with companies that try to implement it, then we often get into the discussion like, how precise is my answer?
Exactly. Yeah.
Because a language model is still kind of a statistical approximation of an answer, right? It just kind of has all this text, and then they say it's just generating words, and somehow it is generating the answer. But there was never like an if this then that, if is then that, and this is the answer. But if you create a vector database, that's already a more certain answer sometimes that you can get, because it's also statistical, but it's like, okay, we know that these words are very similar, so this is kind of the answer. But then what I see as well is then companies develop first maybe a simpler model, right? Maybe just indeed if else, or some decision tree, or sometimes just looking for certain text in a document to maybe classify a document. And then they say, my model works, but I want to use generative AI because I think that will be better. And then the discussion is often about, now, because your model is so simple, you just have if else, if else. If I find this word, then I classify this document as type X. And if I find that word, I'll classify it as type Y. But if the language model doesn't know it, it will just hallucinate an answer, right? So sometimes it's still even better to keep on using these simple models for classification. And then when you don't know it, or when there's like this another like probability that you wanna use, like, okay, I don't know what it is, but maybe there's 60% chance that it's gonna be that, then you can start like mixing things. But if you just use if else, you might already derive a very good answer that you are sure, right? And that's the problem that I often see and often discuss, is like, if you use another approach, your probability of being correct can be much higher than using an LLM.
So it's not a one fit solution, like
no, indeed. And I think because
some
that
like
yeah,
I should try the market try to like sell it like that, like this. But, yeah.
And I think where it comes from is ChatGPT, because I asked ChatGPT a question. I don't know, I will just come up with something, can I take tomorrow a flight from LA to New York?
Yeah.
And then it will give you the correct answer, right? or you do it in another AI like Gemini or whatever. It gives you the correct answer. So people say ChatGPT is an LLM, is a generative AI model. So the model generated the answer.
Yeah.
But it's not always correct. Because what they did is they also have a lot of if else, if else, if else within their model before it goes to the generative AI model. It will check for keywords like oh, you are looking to book a flight, but I have this Google API here that I can query to give you the answer. So I'm not actually going to the generative AI. Maybe not yet. Maybe I will first get my data from Google, get an information, feed that to the language model to give you a nice answer. But the answer didn't come from the knowledge within the AI model. So this is something I think that a lot of companies, organizations that are trying to build these things, they will have to start adding to this kind of logic to their model. They will have to look for certain keywords and build kind of a model on top of the language model, right? Because they might have an API as well that can give you certain answers, right?
Absolutely.
They might be able to give you the answer straight away. They have a vector database that you might get some information, right? So it's not true that whatever you type in ChatGPT just goes in the model and comes out. That was actually the first version was like that, right? And then you said, what is 5 plus 5? And it would give you the wrong answer, right? Because it found somewhere like 5 plus 5 is 9 or something. And then, but now it's like 5 plus 5. Okay, that's a calculation. So I will just calculate it for you somewhere else and then give you the answer. And the answer still looks nice, right? Because it gives you in text the answer, but it just means that it was enriched. And this is also a RAG, right? It's also you're enriching your question already with the answer in somewhere, and then the AI just gives you the answer in a nice conversational way. And as an end user, it might not. Yeah, as an end user, it might not always be clear. So people often start like, oh, I need to have this generative AI model, and then I need to retrain it because it needs to give me the perfect answer. And I don't think anyone is using it like that. I mean, the big companies, right? They are just like layers and layers on top, have built layers and layers on top of that to go to other API endpoints and to get some information and
which provide facts, which also is not
yes,
unimportant. Those APIs provide facts. It doesn't need to be. It needs to be interpreted.
No, but I think that's the difference. That's the difference. I think providing facts means probability 100% of correctness. Going through the LLM, you don't know whether the answer is correct, and that's kind of the issue that a lot of people have, right? It's like you say generate me code to deploy an application to do an API call. It will generate that code, right? But
exactly,
how do you know the code is correct, right? Then say, oh, well, the people are saying like, I had this AI generate my code and it compiled and it worked, so it's correct. It's not always like that, because I've also let it generate code, and then it's like it's generating code using the wrong version of an API. It starts generating with a V1 that is already deprecated, almost deprecated, or was deprecated instead of a V2, right? So it can look correct. And that's the interesting part about generative AI, I find, is like, it's so authoritative. It's like, this is the correct answer. Okay, I believe it. This is the correct answer. Yeah, I believe it. But because it's so convincing, you just believe it, right? But it can be as well not correct, right?
Oh, you want a flight from LA to New York? Okay, let's build a catapult that can carry the weight of a human and stuff like that. Yeah, but it's also a valid answer. But nevertheless, if you can do it to the API of Google, like the certainty of the results that come back from that are like almost 100%. Obviously, doesn't need to make stuff up. Like,
I think we want to go to a much higher probability of it being correct, but we are just not there yet, right?
I don't know.
And what is happening now is that the companies that are implementing these LLMs, like within their business, like there's an airline that did, I think it was the Canadian airline, I think, or something, and there was someone who asked the question, what is the procedure for X? And it gave completely the wrong answer, but it referred to the correct documents, because that's probably the document that is found somewhere in a vector database, but it still gave the wrong answer. And he actually went to court and he got right. He said, okay, he provided me the wrong answer, but I believed it, right? And that's then I want my money back. I issued a refund after I have flown, and people said, "Oh no, you had to do that before." And then he said, "Yeah, but your AI chatbot told me to do it after, right?" And he actually
Yeah,
he won the court case, right?
which kind of makes sense
But
because if a representative was undertrained and would give that information as well, like it would be the same case, right? But
yes,
it's hard to be. It's like it found that info and assumed it was
yes,
correct.
and
Like
it's difficult to see when information is wrong because it's giving you the information, right? You would have to go to the document. So there's still a lot there's still a lot of work needs to be done to get
quality and exactly.
the quality right. Nevertheless, there are a lot of companies that I talk to that are trying to implement that have this. It's just when we're starting to do data analytics, right? All this data that we had somewhere that is underutilized, and then we will find gold in our data because then we find the customer that we can sell more, and then it will be all worth it. Right? It's kind of the same as it used to be, right? Now we have all this data, and it's not in our language model. We cannot ask it any questions. We can not do this exploration, right? So let's bring this data that we have in our model, and that's what a lot of companies are doing. They say we have a lot of data, and I want to bring that in a model. But there's definitely a lot more work necessary rather than just either retraining or using a RAG to get the right answers. But the models itself, they're also improving, right? Because if you look at the models that you have available within BedRock or just other models, like
Absolutely.
you have Llama, right? Which is open source by Facebook that you can just use on your machine. I just installed it on my own machine. You can just ask local questions. And then you have so you have the Amazon model that you can use. I haven't experimented too much with it, but it's definitely usable. Well, must be a lot of users already using it, and just because it's also quite cheap, it's very convincing to use that model for if you are on Amazon. And then there's another open source model like Mistral from another company that is interesting to use. They also open source it, so you could kind of run it anywhere. And then there's also Cloud that is set that you can have a lot of input. So those are like the models that I looked at that are very interesting. That also our customers are looking at to implement some new tooling to create some like build out these new business cases using AI.
It's an
But
interesting time.
it's a definitely interesting time, but I think it always uh, goes back to if you want to do something more advanced, GPUs cost a lot of money.
Yeah,
Uh,
absolutely.
if you think about it, I think the price should kind of lower, but it doesn't because there's now a shortage of GPUs. But if you look at the EC2 instance types that Amazon provides, they're already there for quite some time, like the GPUs that you can use, but they're very expensive. So now there's also other cloud companies saying like you can use our GPUs, and we are much cheaper than Amazon. So even though that you run maybe your app, the backend, the front end, everything runs on AWS. Maybe if you need GPUs, you don't necessarily always need to use AWS
Yep.
infrastructure. You maybe should also have a look at all those external companies that the new companies that are popping up that are also
Yep.
buying GPUs, that are also building an API.
Absolutely. Which you can use maybe just to train the model and like it depends on
Train,
the use case.
retrain. Maybe
Yep.
inferencing you still want to do on AWS. So inferencing is just you ask a question, and
Yep.
then it starts generating the answer, right? Inferencing you might still be able to do because you then just move the model to AWS, you copy the model in S3, or then you start a machine that has GPUs to generate the answer. Generating the answer also costs a lot of money
Yep.
because
If you see the
every
offers we make to those companies, like they always ask for like a cost estimate of the infrastructure. Like even for relatively small things, it becomes expensive quite fast. Like it's
because GPUs
yeah,
are expensive, and for the inferencing inferencing is also still expensive because you have all these text, and all these text you're still feeding in the model to get the answer, right? So you just when you run it locally, you just see it going slower with the
Yeah,
longer
the more info.
questions, right?
Yeah,
But the more information you provide, the slower it goes, the more CPU or GPUs it takes to give you the answer, right? So yeah, there's definitely a very high cost involved right now to build a solution like that. And then so that's when you have that's when you need GPUs, right? So if you use BedRock, you just use API, you pay per token. There's some pricing there that you can look at. On the pricing page, you just pay as you go. But once you
yeah.
have a model that is being used quite a lot, maybe you want to run it on your machines, then it can get also quite costly. And then this might get interesting training, retraining, fine-tuning, inferencing to just find the cheapest provider. I would say sometimes I have a discussion with someone like, why don't you just look for the cheapest provider? It's just an API, right? So just
Exactly.
connect your app to the API, whether it's at Amazon or somewhere else in the world. Like the 100 milliseconds difference, if it's even 100 milliseconds, right? Sometimes like it's 100 milliseconds between New York and Germany or something, right? So
Yeah.
within the US, it's often like negligible. And then even then, the where they are putting those GPUs are often close to Amazon data centers as well, anyways. So they're not like super far away. So I think the latency is negligible. So you can just use that via API, build some software here. Your model is here. You ask the questions, and then you don't have the super expensive GPU price on Amazon to do these things.
Later on, you
But
can still see it consolidated together, or if you have a clear view of what you're going to use. But especially in the beginning, it's sometimes hard to see what the requirements are and what you need, and they change quite fast as well. Or you start to scale a lot, and then like because it's pay as you go, not necessarily every action is going to gain you money. Like so it can become quite expensive really fast. So that's definitely a good solution. It's like you
there's
said, it's
definitely
just a
there's definitely prototyping involved, right?
yeah, yeah.
So if you want to train a model or
E-
fine-tune a model,
Like there's like last couple of years there have been a lot of companies like AI companies started, obviously. But if you see the amount of money that they raise and how much they spend on like actually training the model, which kind of makes sense because the model can then be sold if it's like really valuable. But it's like obscene to see like such amount of money go to um, just the resources to be able to train it.
the
So
funding, right?
you obviously have R&D and stuff like that, the cost and super intelligent people who are able to develop those things. But if you look at like just the hardware cost of it, the amount of money that they're spending on just seeing if their model works and training the model is like it's
Yeah,
golden times for cloud providers, I think, for that
and
part.
that's why coming back to the rack, right? That's why for so you have people that work with a model, but most people will not never have to really touch the model, I think, because
No, I don't think so. Yeah.
that's already a quite advanced use case. And that's why you have the rack. So the rack is just like, I want to use the model, but I have some third party information. I have some documents that I want to inject with a database, with an API. I enrich, ask the model, get an answer. And I think that's where most people should probably look if they like just for like business cases, not like there's a big difference between I'm building a business case on generative AI or using generative AI, or I am a tech company and I'm going to build my own model and then
Yeah.
I'm going to sell it to other parties, right? If you are here in the business, there might not be an immediate need uh, to do all this advanced work with the model itself. It might be
Exactly.
beneficial. It might be beneficial at some point, but initially, the rack is kind of so simple. You just provide the context, just try to get the answers that you need, and then don't forget that it's only the generative AI that is new, right?
Yeah.
So all the other things already exist for 10 years, right? So 10 years ago, I was working also with these models. You had neural models, which is like now AI is kind of the next generation of all this. Um, but we already had all these simple models, like language models, with small language models, or just trying that, like just a regression, like in Python. This all still exists, and this is all still valid to use. So you might still also combine this with models that you want to use, but the interface it's also about just the interface with the user. The interface with the user, if you just want to be conversational, then you always want to feed it back to the generative AI and present a nice answer or interpret the questions, right? But around this AI model, I think there's still a lot of work. So not really in the model itself, but all the technology around. So if you're building like a new company, you have some data that you want to use, then a lot of effort is going to go in, okay, I need this info in my vector database. Maybe I need some other model that is much better in predicting the result or the outcome that I then will feed using RAG to my modeling and present the user a nice answer. But that's a combination of all these things. And it's only it's only what I said, the generative AI is new. With all these other models, there's a lot of software available, a lot of libraries. Most people use Python to train models. We often don't need GPUs to train it. Okay, it goes faster with GPUs, but you can also use normal hardware. Inferencing is not so resource intensive. So this whole package might be kind of your product, what you want to achieve, and you might not really want to achieve being able to train your LLM very well. Eventually, yes. Eventually, maybe that's where we are going to, right? Eventually, we will have such a good model, generative model, that you don't need all these other models. But today, I would still say that a lot of companies are focusing on getting the answer right. And if we can do it without the language model, the probability might be even higher.
Yep. That pretty much sums it up, I think.
Yeah. And like the technologies within AWS, if you are on AWS, to look at BedRock for the language model, vector database. Serverless is more expensive, so if you use what is the open source serverless, more expensive. There's a open source that's not serverless that also falls on. I think the smallest instance falls even under the free tier that you could use. And then SageMaker for your IPython notebook to do your prototyping. And then eventually you will have to build some kind of API, right? A backend. So you still need to deploy an application. Within SageMaker, you can also deploy your API. So that might be an easy way to just build something in SageMaker and deploy it. If you're not very familiar on how to deploy it separately in a container with Python or something, then that's a good way. And then indeed, if you then use BedRock, it doesn't need to be expensive. It definitely doesn't need to be expensive. I think when you talk about racks and you're not immediately going to go to knowledge base as the service within AWS, but you're going to build the pieces yourself, it's not going to be expensive. You just need to store information as tree. You store the information as tree. Use tooling like TextRact to extract the data from PDFs and others. Then you have your files, your text. This you then put in your vector database, or you use to then use as a context to your AI model, or use SageMaker to have some other models, or when the user asks a question, you try to determine what is the question. Should I first go to an API? Should I go to immediately to my to BedRock or to ChatGPT or whatever that you use as generative AI? And that's kind of the architecture today. Maybe next week maybe it's not completely different. Today, I think that's what most people are looking into. Yeah,
it's a fast-paced landscape. Absolutely.
Definitely.
If you look, but it's also interesting, like to be in the space as well. Like it's always interesting.
Once you're a little bit older and you're some years in technology, we already have seen this, right? Virtualization. Suddenly everyone is using virtualization. Big data. Okay, everyone is using big data. Cassandra, HBase, Hadoop, and everyone is using that. But if you then look at the big data space, there's not that many companies left. You see,
Yeah.
there's not a lot of technologies left. There's only a few technologies that really start like to appear as the winners. For example, Apache Spark, Databricks. I think that's one of the winners. And then of course the cloud providers then came, and
Yeah.
those are also the winners, right? Because you can much more easily do big data using something like S3 instead of Hadoop, right? Or you can have Hadoop on S3 still. Okay, now we are going very far, but yeah, you see those things, and then now we are talking about all these models and all these technologies and how we are doing it. But in 1 year time, it will most likely be different. There will be a more clear winner, and that doesn't mean that you don't have to work on it today, right? You can always refactor later or use different technologies later. And I think if you look back on what we did, once you know how to work with one technology, it's very easy to transfer to another technology. So you just need to kind of get into it, follow what is going on, and then you will see winners appearing, use their technology.
Like it's the industry, right?
Yeah.
It's the ability to adjust. And the cool thing about being in a consultancy company is that those questions of new technologies reach you really fast in comparison to the staffing option, because like there's not that many people familiar with it, so they reach out to the companies that have experience with it. So that's something I find really interesting, because you get thrown into it really quickly, really fast, and yeah, that gets me out of bed in the end of the day. Like to be able to get this transformation and these new things. If I still was a how should I put it, typing like Ansible scripts and being an Oracle DBA, for some people consistency is like their thing, and for me it's like change. And so this is very welcoming for some new breath in, like some new air into the whole ecosystem. And basically, at the end of the day, if you see when we're guiding clients, it looks all complex, but with those LLMs that Amazon provides already, they've already been like pre-trained, obviously, but also they already fit use cases. So you don't need to reinvent the wheel over and over and over again. You can get started, get off the ground, like get on the ground running. I think the quote is, but like that really helps as well. No, I think that pretty much sums it up. Do you have anything else you want to share, maybe?
I think because it's so fast paced that we'll definitely do another podcast
Yeah,
soon-ish.
it's like discontinued, and then the next one will be maybe something else.
Yeah. Forget everything that I said. This is the new
Oh,
thing.
yeah,
Yeah. There's definitely a lot of innovations that are going to happen
yeah,
that might change the landscape. I think AWS was very fast in implementing something like BedRock and the knowledge base, because there's so much of their user base asking for it. But there will definitely be, if you look at ChatGPT, for example, OpenAI, you see that there is still some new things that might be released that might change things. And also, what I also find interesting is that today it costs a lot to train a model to do the inferencing, but last year it costed so much more, right? So it's
yeah,
already, the cost is already going down, right? So where
exactly.
a company needs 100 million from its funding to train their model, now it already needs so much less. And then if you look at these companies that now that are specializing in specific hardware designed for
With that,
training or inferencing, like that can definitely help to drive the cost down, right? Because a GPU, it's kind of still the same GPU that we bought so long ago, right?
yeah,
To
exactly.
play our video games, it's the same kind of way that is being used now, right? So if we can build, it's a little bit like when you think about the ASICs for mining, right? First, everyone was
Exactly.
mining on CPU, and then on GPU, and then now you actually built silicon specifically to this for this mining operation. And suddenly, everything
Yep,
else
exactly.
everything else is worthless, kind of. You're not going to mine on the CPU anymore, right? Now everyone is doing it ASICs. So I think the same trend will appear with AI. It will become super cheap eventually.
Yeah,
Uh,
at this price point because there's such a big market gap in if you can jump in that space and do it at a fraction of the cost, you will have market dominance really quickly if you can do it really cheap, basically.
yes.
And actually, if the like if you see GPUs are more like because they didn't have to carry like the instruction sets. They don't have a legacy like CPUs that needs to like carry the instruction sets of so many generations before that because it's an agreement, so they kind of jump into that space. But also like the GPUs are now, the market is quite if you look at the stock of Nvidia, it's soaring because like everybody needs them. We want to do this, we need this, so they basically can decide the price as well. So unless there's like the ASIC equivalent of the GPUs coming into the market, it will still be quite expensive because the hardware is just such a, like so expensive. So if there's some equivalent to the ASIC for them Bitcoin and crypto mining in comparison to for the LLMs, yeah, we see an
And
interesting.
it might even be Google or Amazon that comes
Yeah,
out with it, right? Because
a
I
lot of
think
people.
the the big customers of Nvidia are just Amazon, Google, and Microsoft because they want to build these capabilities within their cloud that you can rent these GPUs or that you can use BedRock. They need all these GPUs to have this capability to be that you can use BedRock. But they also will have made the calculation that, okay, one GPU costs so much. So if we can design something that is, and I think Google is already doing this, right? These LPUs. So if we come out with some custom silicon, just like they already did for their own machines, just not for inferencing. Well, they actually have an inferencing type as well, but if they can do it at a much lower price point, then suddenly you have a big winner there, right? If then suddenly everyone will want to use that cloud. So if any of the three big cloud providers can do that, then they will have a lot of customers coming to them because if this is now what everyone is looking for, then yeah.
The other ones will then catch up and like yeah,
Yeah, of course,
like
of
the
course.
time, but like no, okay, awesome, nice to talk to you about this, Edward. I'll see you soon in the next episode. Thanks for your
Yeah.
time.
See you
Soon,
soon.
bye bye.
Bye.